I bet you anything it's all fine.
That's just real. That's Zoe.
Oh, so the other one was like 5. So there's like I hate homework. That's who started like I was texting yesterday all at the same time. You're not gonna guess because you're really You, Bailey, and Lacey.
I was texting, like, I never text a lot of people.
Oh, I was texting 18 people yesterday.
Oh man, I was putting myself for 5. Leave me alone.
Sorry, my
I've done that.
And like, if you could
I
text or that something else.
I think that was driving me nuts. Like, I was really proud of it. I'm sure you guys just like,
Because they were texting me.
Hannah, just stop. Just stop.
When I'm bored, like, 30 texts.
I was like, oh my god, more than everyone gets
really stupid at this time. Yeah. Wow.
I just put myself for 5. Leave me alone.
You, Lacey, and Bailey. And Bailey texted me first. Lacey told me to text her.
Remember when I was younger, I used to text a lot.
I used to text
on my chocolate and I would like memorize how many times you press it to get like a
That said like too much effort.
It's like, if you need to talk or you can call me.
my phone would be like blowing up. What did I do?
Before I take questions on the homework that you guys are about to turn in, let me just remind us of a few things. I think these are the things that we'll be accessing mentally as we go through these problems. The pH scale is a gradient measuring how acidic or how basic something is. Acids, high on hydrogen ions, low on hydroxide ions. Bases are exactly the opposite, low number of hydrogen ions relative to the number of hydroxide ions. In between 7, neutral, which is water, there should be an equal number of H and OH. Think if you have an equal number of H and OH, that is water. We also know pH stands for power of hydrogen. You can see that when the hydrogen ion concentration, or rather the molarity of the hydrogen ion, is 10 to the negative pH power. We also know then you can solve that out, and the pH is the negative log of the hydrogen ion concentration. As well, we said in all cases, the hydrogen ion concentration times the hydroxide ion concentration is 10 to the negative 14th. For this particular assignment, we said anytime we see H3O+, we're going to replace it with H+. Anytime we see the word hydronium, we're going to replace it with hydrogen. Also remember that in the titration, we're talking about a neutralization, and in order to be neutral, the number of hydrogen ions, which I should say the number, let's just say the moles of hydrogen ions, should equal the moles of hydroxide ions. This would give us an equal number of both, which would imply the pH of 7. And that's what we would be after. Let me grab a calculator, anticipating a log problem, possibly. I just want to be able to make sure that I can work through all of these so that we are as certain as possible that we have the right answers. I think this is the basic information from which to work. There may be other things, but we'll take it as it comes. Anyone have any questions? Skyler? Okay. Okay. So, page 393, number 15. Okay. So, part A says, what is the pH of a 0.01 molar solution of HCl? And they tell us to assume complete ionization. That means that all of your HCl is going to break apart into H and C. Now, if you want to know the pH of any solution, you need to know the hydrogen ion concentration. And as soon as you know that, you plug into the formula and you're done. So we're going to work towards this formula. Let's look at the dissociation of HCl. HCl is going to break apart into H and Cl. The concentration of the HCl is 0.01 molar. Because there are 1s as all the coefficients, the concentrations of the hydrogen ions and the chloride ions will also be 0.01 molar. And now, we know what our hydrogen ion concentration is. We can plug into the formula. Negative log of 0.01. So grab out the calculator, 0.01, take the log, it comes out to be the opposite of -2, which is +2. In some sense, not unexpected, HCl would break apart into hydrogen ions, would have to have a pH less than 7, and it does. Okay, for the next part, it says, B, what is the concentration of the hydroxide ions of a 0.01 molar solution of NaOH? Here, they're not even asking for the pH, they're just asking for the OH concentration. Look at the dissociation equation. NaOH will break into Na and OH. The concentration of the NaOH was 0.01 molar. Since there's coefficients of 1, the concentration of the ions is also 0.01 molar. And that answers the question. The concentration of the hydroxide ions is 0.01. Anytime you're given the molarity of the solution, you can always look at the ionization equation to come up with the molarity of the ions. Yes?
I get confused when you're supposed to say that the hydroxide ions and the hydrogen ions are the same, and when you're supposed to do the equation to figure out one of them. Like, I don't know, that's a stupid question, but
I don't know if I
like,
follow.
for that one,
Mm-hmm.
instead of saying like, since like the hydrogen ions were 0.01 for say even the first part,
Mm-hmm.
the hydroxide ions would be that, I did the like the hydrogen ions times the hydroxide ions equals 10 to the negative 14, and plugged in the hydrogen ion. So I get confused which one you're supposed to do when you're supposed to do it.
Okay.
I don't know if that's a dumb question.
No, I don't think that's a dumb question at all. I think what you're not realizing is A part and B part are separate. Like, A part and B part might as well have been numbers 15 and numbers 16. They're separate situations. Because this situation above, and I may be misinterpreting your question, it's possible, but this situation above is talking about dropping HCl into solution, and this situation below is talking about dropping NaOH into solution.
Okay.
Does that help?
Well, I was also kind of confused on, like, it's a different problem, like 11 and 12. They give you the hydrogen ions and ask you to find the hydroxide ions.
Mm-hmm.
And at first I just did, like, since they give you the hydrogen ions, then the hydroxide ions would be equal to that. But then, as I was looking after it, I was confused if I was supposed to use that equation or not.
Okay, so let me try to address this question. When you assume that the hydrogen ions equal to hydroxide ions, that is in a situation where you have neutrality. If you're not neutral, the only thing you can say about the hydrogen ions is this. And frankly, even if you are neutral, you can say this as well. This works in all cases. And if you think about it, obvious. So if your hydroxide, or if your hydrogen ion concentration was 10 to the negative 7, in other words, your pH is 7, then your hydroxide ion concentration would also have to be 10 to the negative 7 for the 2 to multiply to be 10 to the negative 14. I say that because in this case here, where the pH is 7, you can make this statement. This is only true when the pH is 7. So when is the pH 7 in a titration where you're neutralizing something? But in this problem, there's nothing neutral about an HCl solution. He's got an excess of hydrogen in it. There's also nothing neutral about a sodium hydroxide solution. He's going to have hydroxide ions floating around in it. Does that help some?
I think so.
Okay, Olivia?
How do you know which equation to pick of those three? Like,
It depends on what the question is asking. So here, this says, what is the pH? So if we're solving for pH, I'm going to try to find an equation that has pH solved for it. Here, this is, what is the hydroxide ion concentration? Really, the only equation that pops out is this one. But as soon as you write out the equation, which is a good first step in any problem when we're talking about acids or bases, you can see you already get it from the equation. So there's nothing more to do than that.
if they, like on number 11, they asked for the hydroxide, and the first part they gave you the pH. Is it wrong to plug in the first equation for that, or do you always have to do the bottom equation?
And tell you what, I'm going to finish, because you and Jordan both have questions on 11 and 12. I'm going to, Holly too, perfect. So I'm going to finish this question and then we'll get to 11 and 12 right after that. So, and I think actually C part is going to give insight a little bit to what you're asking about. So C part says, what is the pH of this NaOH solution? Now this NaOH solution is referring to that guy. So the equation that we have of, well, I don't even need to rewrite it. It's over there. This equation here, I guess, let me extend this. Thanks. That's the sodium hydroxide solution we're talking about. Now the question is, what is the pH? Now, again, if they ask a question about pH, my instinct says, let's find the pH equation. And now that gives us a new thing to look for. To find the pH, we need to know the hydroxide, or excuse me, the hydrogen ion concentration. So now we're saying, what's the hydrogen ion concentration? Well, how can I figure out the hydrogen ion concentration? Well, over here, if I knew the pH, I could find the hydrogen ion concentration. But that's not going to help us because we don't know the pH, that's what we're looking for. The only other place where I see a hydrogen ion is down here. And that's actually able to be used because we just did in the last problem the hydroxide ion concentration. And if we know the hydroxide ion concentration is 0.01, then we can figure out what the corresponding hydrogen ion concentration is. So if we know that in any water-based solution, the hydrogen ion concentration times the hydroxide ion concentration is 10 to the negative 14, we can, from the previous problem, sub in the information that we had. And if you take 10 to the negative 14, turn off the calculator, it's rather finicky. On button. Okay, so 10 to the negative 14th divided by 0.01. The hydrogen ion concentration is 10 to the negative 12. I mean, in a sense, you already have your answer here, because the hydrogen ion concentration is always 10 to the negative pH power. You've got it already. If we plug back into the other equation, we'd have the pH is the negative log of 10 to the negative 12. In either case, you get a pH of 4. Because you can see the pH here from the equation. Hydrogen ion concentration is 10 to the negative pH value.
On my calculator, it says 1e to the negative 12, so would you just write that as 10 to the negative 12?
Yes, so here's, let's think about what this means. When you see 1e negative 12, this means 1 times 10 to the negative 12. And 1 times anything would just be that anything. So that's where I got that. I guess I could have wrote that out as intermediate step. That would be what your calculator gives you, and this would be how you would interpret it. So maybe that gives some insight. Now let's go to 11 and 12 and see what we get from them. These are also page 393 in the questions. The hydronium ion concentration, so let's take out hydronium and say the hydrogen ion concentration. The hydrogen ion concentration in a solution is 1 times 10 to the negative 4. A part says, what is the pH? Well, we know the pH is just the negative log of the hydrogen ion concentration. Let's just solve here. Negative log of 1 e negative 4. 1 times 10 to the negative 4. So, put that in the calculator. 1 e negative 4 inside the log. The pH is 4. Shoot, if you look hard enough, you can see the hydrogen ion concentration is just 10 to the negative 4. There's the pH up there in the power. But in any case, the pH is 4. Now, part B says what is the hydroxide ion concentration of this solution. To access what Jordan was confused about earlier, and presumably she's not the only one, we can only say that the hydrogen ion concentration equals the hydroxide ion concentration at a neutral pH. If we are not neutral in pH, we're in one of these scenarios. And we know already from the beginning of this problem that our pH was 4. We're in a hydrogen ion heavy solution. So when we come over here, we're going to use our equation, hydrogen ion concentration times hydroxide ion concentration equals 10 to the negative 14. Or thought in other words, in calculator terms, 1e to the negative 14. We should be able to plug in here. The hydrogen ion concentration was 1e negative 4. So we can divide. And if you take 1e negative 14 divided by 1e negative 4, you get 1e negative 10. In other words, the hydroxide ion concentration is 1 times 10 to the negative 10. Notice the hydrogen ion concentration is only a 1 divided by 4 tens, whereas the hydroxide ion concentration is a 1 divided by 10 tens. This is a smaller number than that number. Divide by 4 tens or divide by 10 tens. Dividing by 10 tens is going to give you a much smaller number. If you wrote this out, it would be 0.1, 2, 3, 4, 5. That would be the molarity of your hydroxide ions, and your hydrogen ions would be that. So you can see, looking at those two numbers, that the hydroxide ion concentration is significantly less. And that's consistent with the fact that at a pH of 4, you're going to have a glut of hydrogen ions. Is this helping? A little bit? Clarifying, hopefully, the confusions. So if we look at 12, here. If we look at 12, it says the hydroxide ion concentration of a particular solution is 1 times 10 to the negative 6. Question A, what is the hydroxide ion concentration? It says hydronium ion. Oh, excuse me. Let me pause for a second. It says, what is the hydronium concentration? Which we know what is the hydrogen ion concentration. Well, if you know the OH, you can find the H using this equation. So the hydrogen ion concentration times 1e negative 6 equals 1e negative 14. Divide 1e negative 14 by 1e negative 6, and you get 1e to the negative 8, which means 1 times 10 to the negative 8. You could also write that as 0.00000001 molar. So either of those would work. 1 times 10 to the negative 8, or point with 7 zeros and a 1. Because to hop the decimal place here, you have to hop 8 times to make 1, with 7 zeros. B says, what is the pH of this solution? Well, if you know the hydrogen ion concentration, you know the pH, because the pH is always the negative log of the hydrogen ion concentration. So it's the negative log of 1 e to the negative 8. So take the log of that number, and you get the pH to be 8. If you look hard enough here, the hydrogen ion concentration is 1 times 10 to the negative 8. The pH is actually snuck up in there, not in that power. So he's hit. In a sense, you could have got that value without doing any computation in the last problem. Or you could go to the equation and compute it directly. Either one would work in that case, because it was a nice round number to start with. Yeah, sorry. 24? Okay, so 24 says a solution is determined experimentally to have a pH of 2.9. They actually have devices that you can, they're battery powered, that you just dip a little metal probe into the solution and it'll tell you the pH instantly on a little digital readout. Pretty cool devices. So we determined experimentally, presumably with one of these devices, that we have a pH of 2.9. So the question in part A is calculate the hydroxide ion concentration. They use a hydronium ion, but we know how to replace. Now, if you know the pH and you want to know the hydrogen ion concentration, that's your formula right there. So the hydrogen ion concentration is just 10 to the negative 2.9 power. If you want to, you can just leave it as that. That would be fine as a hydrogen ion concentration. If you want to as well, you could just, in your calculator, raise 10 to the negative 2.9 power. And see what comes out. And you get 0.001259. That would be your hydrogen ion concentration. That's just taking the number and plugging it out in the calculator. But frankly, either of these are okay. If you have the pH and want the hydrogen ion concentration, you can go right to the equation. For B part, it says calculate the OH minus. Now, again, this is going back to Jordan's point. While many problems involve an equal number of hydrogen ions and hydroxide ions because you're neutralizing a solution, in this problem, we are definitely not assured of that because our pH is 2.9. We're very acidic. So we should expect the hydroxide ion concentration to be significantly less. To go to the formula, hydrogen ions times hydroxide ions is 10 to the negative 14. We know that the hydrogen ions is 10 to the negative 2.9.